All right, so as promised, here's the definition where we've got a function with three variables and how to deal with it. It looks like the same limit function that we had before, only there's a z thrown in there as well. So again, the first one here, we're only doing with respect to x, so it's x plus h, and then the y and the z don't change. Uh, Same thing for the y. You take the derivative with respect to y means we take the y and add some variable instead of h. Now we're using k and so forth. But again, I'm going to stress you probably, again, you can use this. It'll just take you a lot longer to do them. But I would stress just taking the derivative in a natural fashion where if we're doing with respect to y is the variable and any other variable looking thing is a constant. And that should be pretty easy to deal with. Something else this section, little area talks about is second derivatives, or even third, fourth, and fifth derivatives. So this should look like very close notation to what a second derivative looks like without the f, essentially. Um, it would be like d to the y, so I guess f would be your y there. And then the superscript 2 in both the numerator and the denominator for what you're dealing with. And then this one is the same thing, only with respect to y, so the second derivative of y. Now, and again, the order of what you would do with the chain, you would do what's inside the parentheses first, and then take the derivative of the outer, of what's in there. And that's, again, pretty straightforward, pretty intuitive. You should know how to do this. It's these two in the middle that are going to be problematic. And I actually prefer this other notation. So looking down here, that we have this f(x(x). The first x is the first derivative, the second x is the second derivative. Similarly, fyy, we take the first derivative with respect to y, second derivative with respect to y. These other two, I think, are more intuitive than what's written above. So this one right here, f of yx. So that means we take the derivative of y first, then we take the derivative of x. So above, we do the derivative of the y first, which you see in the parentheses. And once that's done, then we go out and take the derivative of the remainder with respect to x. That's how you do it. I think the other notation, the f notation, is a bit more intuitive as to what you're supposed to do in what order. Whereas the other notation looks more like the reverse order. Especially if you look here, it has dx first, then dy, when in reality we're doing the y first. So be careful, and I typically will use the f notation. So I'm going to do a couple problems. Number 130, the first part, we just need to find the second uh, the second derivative, essentially what we have here. Oh, that's not what I want, but that's okay. We're going to look at this formula here. We're going to take the derivative of y first, then the derivative with respect to x. So d2f dx dy. Our first one is, I guess we just want df dy here. So the derivative with respect to y, well, the x cubed and the z squared come out, and the derivative of y is just 1, so that's going to be x cubed and then z squared. And so the derivative with respect to x of that is then z squared is a constant, and then we have times 3x squared. And again, you can pull the 3 out if you'd like, but that's our answer to that. The f of z with evaluated at 1, 1, 1. So here we're going to evaluate our derivative with just respect to z. So f at z, the x cubed and the y are all constants, and the derivative of z squared is then 2z. We want to evaluate that 1, 1, 1. So that's x cubed y, I guess we can put the 2 in front, and yz evaluated at the point 1, 1, 1. So that means 2 times 1 squared, because x is 1, times 1 because y is 1, and again times 1 because z is 1. And we have, well, just 2. So not too bad. Number 142, we're taking essentially the second derivative there. So f of x is our first derivative. So we have 4 over y times 2 x to the first is derivative of that first fraction. And then that second one, consider that, so we're looking at plus y squared over 2, and we've got x to the negative 1. The derivative of that would be negative 1 times x to the negative 2. That's our first derivative. And I can clean that up. It's 8 over y times x minus y squared over 2 x to the negative 2. And so fxx is the second derivative with respect to x. And we just have 8 over y, excuse me, because derivative of x is just 1. And then we have minus y squared over 2, and then we multiply by the negative 2, and then it would be x to the negative 3. And I can do some canceling and cleaning. That's just 8 over y. The 2's and the minus will cancel, so plus y squared over x cubed. And that should be our final answer.